find the asymptote of the function and graph of the function. So we have function f of x is equal to x squared plus 6x minus 6 divided by x minus 3. If we are using long division in this function here, we are going to get x plus 4 plus 6 divided by x minus 3. So, and this function here it then is equal with this function. So those are the same. And because they're the same, we needed to find the slant asymptote. To find the slant asymptote, first of all, what we need here, we take in the quotient. So the slant asymptote here, let me write SA, slant asymptote. Here is, if we are taking just the quotient, which is y is equal to the x plus 4. So this linear equation is the slant asymptote, x plus 4. And if we want this to graph it here, so y is equal to the 4 here, and x is going to be minus 4. So minus 4 is right here. And now I'm going to connect to those points. And if we are going to connect to those points, we can graph the slant asymptote here. So this is going to be the graph of the slant asymptote. And now, number 2, let's find the vertical asymptote. So the vertical asymptote, here we take the denominator of the function and we equate it with 0. So easy way. We take x minus 3 or here x minus 3, either way. And we equate it with 0, minus 3. We equate it with 0 and we solve for x, and x is going to be equal with 3. So this is a vertical asymptote. And here is a, let's say here is a 3. So every unit I'm taking 1. And here is a 3. And now same thing, I'm going down. So this is a vertical asymptote. And this vertical asymptote, let me write x is equal with 3. X is equal to 3, and this is a slant asymptote here. The y is equal to the x plus 4 is a slant asymptote, plus 4. So this is a slant asymptote. Let me write SA, slant asymptote. And now 3, I'm looking for the horizontal asymptote. Whenever we have a vertical slant asymptote, the horizontal asymptote does not exist. So because you see the degree of this function in numerator is greater than degree of the function in denominator. So n is let's say is a 2, and the degree of polynomial in denominator is 1. So it means the horizontal asymptote does not exist. Does not exist. Okay, D and E. So it does not exist. And number 4, let's say x-intercept. To find the x-intercept, I am setting the f of x is equal to 0, so I'm taking a shortcut, and I'm taking numerator, I equate with 0. So f of x is equal to 0. I'm sorry, f of x is equal to 0, so let me write a little bit better. And we take in the numerator, which happens to be x squared minus x is a plus x minus 6. Okay, is equal to 0. And now we are solving this. First of all, the factorizing, we are solving for x, and those x are going to be the interception. If we factorize this, is going to be x plus 3 times x minus 2. If we factorize this one, so I'm going to a little bit quickly to do it, is equal to 0. And if we are solving this, then x is going to be equal to minus 3. So the solution is opposite with the factor, minus 3. And here is going to be x is equal to 2. So those are the x-intercepts, equal to 2. and minus 3 is happen to be here, okay, and 2 is right here. So those are the x-intercept. Here is a 2 and minus 3 x-intercepts. And 5, if I'm looking for the y-intercept in this function here, the y-intercept is, we set the x is equal to 0, and now f of x, which happens to be anywhere where I have x, is I'm going to substitute it by 0, even if it has a coefficient, because coefficient times 0 is a 0, and here is a 0, and this is just minus 6 here, and same thing is going here, 0 minus 3, and this is going to be equal, minus 6 divided by minus 3 is positive 2. So the y-intercept here is 0 and 2. So here is 2, and 2 has to be here somewhere. Okay. And in the 6, I am going here to write the domain. What is the domain here? The domain we see obviously is from minus infinity to this intercept here, and this intercept happens to be minus 4. So is from minus infinity to minus 4 and is union from minus 4 to 2 and is union from 2 to infinity. So this is going to be this is the domain here. And now what we are looking here, to graph of the function. So we have all these points. The function has to go through these 3 points. And if the graph of the function goes through these points, we already, let me write here, through these 3 points, has to go through these points. And then by the end, behavior of the function is going very, very close to the asymptote here. Same thing is going to happen on the other side. Is going very close, the end behavior of the function going very close to the vertical asymptote in this side. And already we know the graph of the function in this side is going to be the opposite with this side, and the graph is going something to happen like here. I don't have a lot of space here to draw this function, but n is go toward the infinity as the end of the graph and behavior of the graph is approaching to the asymptote. They are going very close, so this goes to infinity loss. Same thing happened with this here, with these graphs. So this is the graph of the function.